Okay, welcome to warm-up number 47. Let's graph this equation. So we've got an exponential function here. This one is going to be decay. I know that because the base is less than 1, so my basic shape, it's going to be going downhill, something like that. Okay? So it says include the y-intercept and the horizontal asymptote. So the horizontal asymptote comes from this number. So it's going to be y equals whatever that is. Horizontal means it's going to be this kind of a line, which means it's a y equals line. So my horizontal asymptote is y equals 4. So let's just put that in the graph right off the bat. Okay, there it is. All right, and then let's find the y-intercept. So the y-intercept, I'm going to plug in 0, 4x. Okay, anything raised to the 0th power equals 1. So that means y equals 5 is my y-intercept. Okay, and then if it was growth, I'd do an uphill thing, but hey, this one's decay, so I want it to be going something like this, downhill from left to right. It's going to be approaching that asymptote, but I'll never cross it as it goes to the right. Okay, so there's the first one. Next up, how long would it take for $100 to triple if compounded monthly at 12% interest? Okay, so compounding monthly means I'm going to use the exponential growth formula that has the n's in it, the compound formula, like so. Okay, so $100 is my initial amount, and we're going to triple that, so we're going to end up with $300. The rate is 12%, so written as a decimal, 0.12. Number of compounds per year, well, monthly compounds means going to compound 12 times per year because there's 12 months in the year. So 12 goes up here, and then what we don't know yet is the time. So that I'm just going to leave that as t. Okay, then I'm going to start to try to solve this for t. So I'm going to start, I'm going to do a lot of this on my calculator. I'm going to start right there, which maybe you don't need a calculator for that, but I'm just going to keep track on here. 0.12 divided by 12 gives me 0.01, okay? And then I'm going to add 1 to that. All right, so here, let me keep track a little bit here. Okay, next up, what I'm going to do, I'm trying to isolate the t, so I'm going to divide by 100, which you could have done at the beginning, but don't multiply 100 times 1.01. We want to get rid of that 100 like so. You can't multiply those because they have different exponents, 100 to the first and then 1.01 to the 12t. Okay, so now I've got 3 equals 1.01 to the 12t. And whether you divide it by 100 at the beginning or where I did, you should end up here. And now our only option is to go with logs. We're going to put this in log form. So my base is going to be 1.01. Okay, the contents are going to be 3, and then the exponent gets isolated. Sorry, that's written so small there. That's what I wanted to happen. Now the left side of this equation, I can put in my calculator and get a decimal out of that. So let's try that out. Log of 3 divided by the log of 1.01. And that gives me 110.41. And then the last thing is just to divide by 12. Okay, and I'm going to the nearest hundredth, so I'll call that 9.20. And that's years. Okay? All right, next up, let's solve this equation. I've got multiple logs here, so let's start combining logs. They all have the same base, so that's good news. I can combine these two. They have the same base, and when I'm adding 2 logs with the same base, just multiply the contents together. So I'm multiplying 3 and x to get 3x. Okay? Okay, now I could combine these 2 logs by subtracting one of them from both sides of the equation, but there's a shorter way to do this. I've got to get log base 3 of something equals log base 3 of something else. Well, the something and the something else have to be equal to each other for this to work, right? So I can just say 3x is going to equal 45, divide by 3, and then x is 15. Okay? All right, next up, so before we combine logs, you got to make sure they don't have coefficients. So I'm going to use the power rule here. I'm going to take this 2 and make that an exponent. I'll do the same thing with the 1/3. Okay, and then that one doesn't have a coefficient. So this is going to be log base 6 of 4 to the 2nd minus log base 6 of 8 to the 1/3. Leaving the right side alone. Some people might pull the negative up there and have that be 8 to the negative 1/3. You could do that, but then you'd be adding this log. Okay, so the negative can either stay where I left it, or it can go with the 1/3, but then you've got a plus there. Okay, and you should end up in the same place either way. So let's start simplifying. You could combine them now, but I'm going to simplify these logs first because I can do something with both of those pieces. So 4 to the 2nd is 16, and 8 to the 1/3, that's the cube root of 8, which is 2. Okay, and now let's combine these two on the left side together. So when we're subtracting, you take the contents and divide. So it's going to be 16 divided by 2. So I'm going to get log base 6 of 8 equals log base 6 of x. And now for this to work, those have to be equivalent, right? So x equals 8 then. Okay, that's it for this warm-up. See you next time.